Hey guys, welcome back to my channel. I have another interesting video. This is a 2002 Mercedes C240. Customer complaint as a no star. It was brought to us on a tow truck. This car was first at the dealer, and they told the customer that it needs an engine computer because water damage. I did some tests first. The battery was completely dead. So I put a new battery on it. The car started and run fine. I have like some codes. Let me get the scanner so you guys can see it because I connect. First, I tried with the hotel. I'm getting the scanner right now. The car was running fine, and it has some codes in the stability control module saying that cannot communicate with the engine computer. But the engine was running good, so I left it running for like half an hour. Nothing wrong. I turned it off, let it cool down for like another half an hour, and then the car didn't want to start no more. So I read the codes. I connect SEN3 for that, and the codes that I was having, it was some like low voltage on terminal 30 on the computer, and um, and I also noticed that it was a no start enable. But I went over to the ignition module on the switch, right? The ignition switch module, and it says start enable, but not enable on the DME or engine computer. So I'm trying to pull out the information. Sorry, I'm off camera right now. Should be doing this right here. So this is the model of the car. Hopefully it's not too too blurry there. So we got airbag codes, stability control. As you can see, the C1210, terminal 30 too low. Then we have the C1038, which is engine computer not identified or incorrect module. So I erased all the codes, and then just on the engine computer, I was starting to get codes like misfires and still the engine wasn't even running, and then the problem with the no start. So I noticed also that I had a current draw around 6 amps. It went down to like 2 amps and then to like half an amp, which is still too high. So I took a decision and I removed the engine computer. That for those who doesn't know where the engine computer is, it's right here. It's in the engine compartment, right in the fuse box. You need to just lift the hood an extra click. You can push this red button and that will let you open the hood more. Disconnect all the connectors starting from your farther left from the side of the car, right? And then just pull it up. All right, so I pull up the module and it is true. It is definitely water damage. So let me get you guys close to what I'm doing right now. All right, so that's the engine computer. Let me get a light right here. So hopefully you guys can see better. So we have definitely water damage here around this chip and some capacitors in here. Let me actually get the computer close to you guys. I'm trying to let the camera focus. Come on. I don't know if I can just touch in there. Okay, that's perfect. All right, hopefully you guys can see the water damage in there better. I'm going to get a little closer just to do the focus. And so we know that we have problems in here on this area and on this area. So definitely this is an engine computer, and obviously being a Mercedes, it's going to be expensive. So my goal is take this to my bench at home, do a throughout inspection, and try to do an ultrasonic cleaner. I'm gonna put some flux around, heat the bore up, and do an ultrasonic cleaner, then measure the resistors and the capacitors. All right, back in business. So what I was going to do is, I'm in the shop and I don't have my microscope here, but I usually what I do is with a good light and this some glass, I can start to see if there's any damage on the board. I can see a couple of corroded legs on that cheap. The one that has the sticker 188 right here. Yeah, there is three capacitors that are really damaged on the right side. Those are definitely the ones that always take the heat on voltage like that. I got definitely corrosion on this main chip. And for the rest, doesn't really look that horrible. Okay, I got the computer right in my lab at home. As you can see, I set it up already on the desk, and I want to show you how it looks a little bit here on the screen. It's probably the best way to show you since I mean the microscope is it's for me and the screen for you guys. So let me set up the camera right there. So as you can see, we have a lot of corrosion. That third cap looks really bad. The other ones are just dirty. Hopefully the mouse pointer can also help you guys. So the one I'm talking about is right where the mouse pointer is right now. And well, we have a lot of corrosion on the legs of this sheep. It looks like temperature. At least the sheep doesn't have any holes. Let's take a look at the other side. I don't like that either too right here. See, that looks like it might be open, and that might be the issue with the, yeah, definitely that section is really, really bad. Let me show you guys a little more of what I can see here. Look at this. So those tracks right here, again, where the pointer is, are very important. I can, I think the best thing for me to do is try to clean the board and see what I can see after the cleanup, because this is just disgusting. I don't see holes on the resistors or the capacitors except for this one. This one definitely gonna have probably to be replaced. The only way I can check the capacitors is it has to be removed from the board. So what I would do is probably remove this one and check next to, compared to the readings. This one had some sort of a reading on it. So these legs in here are really, really, really bad. At least that's what I can see with all this dirtiness. I mean, this corrosion and how much damage we have, we don't know until we clean it. Definitely water and electronics is didn't go along. Probably ignition coils or injectors. So these are one, two, three, four, five, two, five. Can have injectors because we need six of them. I mean, I don't know how they got it spread out. We got another one at the edge. So they might be, I'll have to look at the diagram and then go around, but that is not important in here for us. Again, let's take a look at the whole board. Yeah, look, this really, really clean. This capacitor is not swollen, which is good. Oh, here is really clean. This looks like fuses. All the legs from the connector there looks really clean. Resistor is good. This one, I am not happy with this one.
Let's approach a little. Hopefully you guys can see what I'm talking about. I mean, it's not 100% bad, but I can see a little crack on that soldering. So those are the kind of things that you need to address. So right here, it's a little bit of a cracking around the soldering. Remember they put this clear coat on it. So it might be just that. It's like a protection they put on the computer to protect it for, for humidity as well, not for water intrusion. Yeah, that was just that. Let's take a look and see what is the resistance in there. Let me put that on the camera better for you guys to see. So this is the component that I'm checking. Gonna put the two leads on each side of this resistor. And it's telling me it's like 5.5 kilo ohms. I'm going to check the next one, which is the same, and it looks good. Let me see. Yeah, 5.6, so I will consider those still good. And this is the meter. Let me show you guys what I'm doing. It's gonna be a little bit of a shaking in there. So, well, right now it says overload because I got no leads connected. I'm going to connect it into one. This is the first one. We saw a little bit of a crack on it. Trying to find the spot. So as you can see, it's 5.58. Now I'm going to the next one, right? The next one, and we got 5.6. So I consider that perfect. Let's keep checking more. And I did check those because right here the board is clean. I was just a little concerned on that little crack, but it was more like the clear coat than nothing else. We're going back to the problematic area where I see this before. This is the part that I'm really afraid of. Let's try to clean this with a little bit of alcohol. Yes, another doggy around, so I don't know how they can do it, but I mean they see through the blinds with the blinds closed and everything. It's like how they do it, no idea. So let's try to clean this a little bit with alcohol. Start to remove just a little bit. See how much damage we can see or not here. When I think about these applicators, hopefully it's the right word. It's so hard sometimes to get into the right position. Okay, I'm right here. Trying to remove that. Okay, perfect. So the pad is good. That's very important. So what I'm going to do is first put some flux here and reflow this, let the flux clean. Gonna first clean a little bit with alcohol. Let's do this around. All right, guys, I'm going to do this a little quick. So let me get to. So as you can see, the alcohol is very good to remove all that junk. So we can see more of what the actual damage can be. Hopefully this customer brought the car quick. I mean, it didn't start on them. They towed over the dealer. The dealer gave him the quote for, a new computer and some other things, and definitely, I think it's like total. The insurance wants to total the car, and she wants to fix it. She has it in new, so it's kind of like a sentimental value for her too. All right. You can see the alcohol really helps to get rid of that junk. Obviously, I'm just going superficial, but that is also a good way to see, because otherwise all we're looking at is just all that junk. I mean, definitely it looks better. All right, now let's put some flux in all these areas. The flux is gonna help to clean. All right, this is how it looks now. So now for you guys to see what I'm doing. Oops, sorry. So that's my hot air gun or a station. And let me set you guys back to the screen. Let me get you to a better spot so you guys can see more of the heat going through. Probably that area is the best. So all I'm going to do is just heat this up without, melting anything. The flux is going to start flowing. I'm going 360 Celsius. I can feel the heat. I gotta be careful with it. It should be good enough. Ooh, I burned the brush. After this, I'm just going to use alcohol again to see how that looks. Obviously, I'm gonna let it cool down. And this is, I mean, procedures to clean and repair electronic parts. Sometimes it's not about replacing anything, it's resolder. That cap, I'm definitely going to remove it. All right, that looks better. We blow some air to it. Gotta take it off the microscope. I'm trying to clean it. It's already starting to look like a different computer. Yeah, that number 2 pin is almost gone to 2 and 4. Got another one really corroded in here. Those are the ones you have to check with the multimeter. Let's see if I can put that in a microscope camera. Well, that's it now. Well, that's second one and 2, 4. What is that? 7. Yeah, they don't look really nice. Need a little bit of alcohol to clean that too. Get a little more. Hmm. So we can check the leg in between that cap that was really burned and that pin is a straight pad. Do the same thing on the other side. I got cheap. Oops, too much. I mean, this already looks like a different computer. Okay, that is good for now. The good thing about the alcohol is it dries really quick. It's kind of like in my way, but we need to. So let's pick this one up here. And that's good. Hopefully you guys can hear that beep. And I'm checking the pads. That one is good. Hopefully you guys can hear the beep. Okay, that's good. That was one of my main concerns. We have this one here too. Let's check this one right here at the tab. If we have continuity here, it's good. How about this one? To clean a little bit. Oops. All right. Come on. Believe me, guys, this is hard. You're working with like needles. Yeah, we got continuity there. So that looks good. All of these legs, they were looking bad. Look at the what a difference now after a minor cleaning. That was not really too too extreme. That looks good. Okay, what time is it? Because it's Friday night and I got plans, so I'm gonna have to stop the video here, guys.